Welcome to the video lecture for section 1.2. This is for college algebra. My name is Jorge Gabriel. So we're going to do objectives 1, 2, and 3. 4, we're not going to worry about that in this particular lecture. So we're going to go ahead and solve quadratic equation for factoring, quadratic equation by completing the square, and then quadratic equation by using quadratic formula. So we've done we did factoring. We haven't solved an equation, but if you know how to factor, you can do number one. And number two, we did that in class. And then number three, this is sort of going to be new. At least we haven't reviewed that as of yet. So the first definition, a quadratic equation is an equation equivalent to one of the form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a does not equal 0. If a was equal to 0, it would just be a linear equation. And so we're going to solve a quadratic equation by factoring. So we have these two equations. We have x squared plus 6 is equal to 0, and then we have 2x is equal to x plus 3. So in the first one, the equation is in standard form specified in equation number 1. The left side may be factored as, we go ahead and factor out an x. We have x times x plus 6 is equal to 0. Now, we have two factors. It's equal to 0, so we can use the zero product property, which means that x is either equal to 0 or x is equal to negative 6. Now, you can't do this all the time, especially if we have a constant anywhere on either side of this equation. And this is what happens with b. So b here, we're going to place this in standard form. So it ends up being 2x squared minus x minus 3 is equal to 0. So in the difference between this one and the previous one is that we have a constant here, namely negative 3. So the left side now may be factored. So 2x squared minus x minus 3 actually factors to 2x minus 3 times x plus 1 equal to 0. We use the zero factor property. So we set each of the factors equal to 0. So the first one is x is equal to 3 over 2 or x is equal to negative 1. And that's our solution set. So the only difference, the extra step here, is that we're actually solving for x, right? We have an equal to something. Whereas when we were just factoring, we didn't have an equal sign, so we didn't solve for x. We didn't care about x. We just wanted to kind of break down the function that we had or the equation. Now, the square root method. If x squared is equal to p is greater than or equal to 0, then x is either equal to the square root of p or x is equal to the negative square root of p. And this is how we solve using the square root method. So here we have a and b. We have x squared is equal to 5, and then we have x minus 2 squared is equal to 16. And so for the first one, x squared is equal to 5. We square root both sides, which gives us the square root of x squared is just x. The square root of 5 is either plus or minus square root of 5. So the solution set for the first one is either negative square root of 5 or square root of 5. For the second one, again, we square root both sides, so we end up with x minus 2 on the left. And then on the right, we end up with plus or minus square root of 16, which simplifies to plus or minus 4. And then what's going to happen here is we have actually two equations. We have x minus 2 is equal to 4, and then x minus 3 is equal to negative 4. So we solve for x on both of them, and we get negative 2 or 6. Next one, solve a quadratic equation by completing the square. And we did this in class, so just a quick review. So x squared plus 5x plus 4 is equal to 0. So then what you do, the first thing is you take the constant and you move it over to the right side. So we end up with x squared plus 5x equal to negative 4. And now what we're going to do is we're going to add to both sides b over 2 squared, which is the 5 over 2 squared to both sides, which turns out to be 25 fourths. So we add 25 fourths to both sides, and this is this line right here. And so here we simplify this to 9 over 4. Now, in this part over here, what happens is when we complete the square, it allows us to do this. So then we get the square root of x squared is x, square root of 25 over 4 is 5 over 2. And the reason we can do that, and we talked about this today in class, is that this is actually equal to 2 times the square root of this times the square root of this. We actually get 5. And so now we find the square root of both sides. And so we end up with x plus 5 over 2 is equal to plus or minus square root of 9 over 4, which is plus or minus 3 over 2. Subtract the 5 over 2, and then we end up with x is equal to negative 4 or x is equal to negative 1. So now here's another example. We're going to go ahead and solve this by completing the square. This is slightly different than the previous example. We have the coefficient for the square term is 2 as opposed to 1. But the process is still the same, right? So we're going to take the constant, we're going to move it over to the right side. Now on the left side, we're going to, let me go back. They actually did a little weird. So they actually divided everything by 2, and that's how we ended up with this over here. Now, there are several ways that you can do this. We could have pulled out the 2 and then dealt with that later. This way is actually a little easier, but I'll show you both ways in class. And so now that we have this, we're going to go ahead and add negative 4 over 2 squared to both sides. And then negative 2 over 2 is negative 2. Negative 2 squared is 4. So we add the 4 to both sides. Perfect square, perfect square. This is 2 times the square root of that and the square root of the last terms, which allows us to do the x minus 2 squared. 5 over 2 plus 4 is 13 over 2. Get the square root of both sides. So x minus 2 is equal to plus or minus 13 over 2. And what they did here is simply they rationalized the denominator. So they multiplied top and bottom by the square root of 2, which gave the square root of 26 over 2. And then once you have that, we just add 2 to both sides, and we end up with 2 minus square root of 26 over 2 and 2 plus square root of 26 over 2. So we're going to solve a quadratic equation using the quadratic formula. So quadratic formula, ax squared plus bx plus c is equal to 0. A does not equal 0. The formula that we're going to use is x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Now, if this determinant, this value in here is called the determinant. If it's less than 0, it has no real solution. If it's greater than 0, then the real solutions are given by this formula here. And so the discriminant of the quadratic equation, so if the discriminant is greater than 0, there are two unequal real solutions. If it's equal to 0, there's a repeated solution, or in other words, a double root. And if it's less than 0, there's no real solution. So we use this to determine whether or not we have a solution before we start doing all the work. So let's solve this using the quadratic equation. So we have 3x squared minus 5x plus 1 is equal to 0. So here we have to determine what's a, what's b, and what's c. And so we take those values, we plug them into the determinant. We find out that the determinant is 13. Since it's greater than 0, there are two real solutions. We use the formula, and then we end up with 5 minus square root of 13 over 6 and 5 plus square root of 13 over 6. And again, we're going to use the quadratic formula to find a solution for this particular quadratic function. And so 3x squared plus 2 is equal to 4x. We're going to move the 4x to the left side, so we get a 3x squared minus 4x plus 2. We got a, b, and c. The discriminant, find out that it's negative 8. It has no real solution to this particular equation. Here's another example. We're going to use the quadratic formula to solve this. So we have 9 plus 3 over x plus 2 over x squared is equal to 0. X cannot equal 0. And so what we did here is we simply multiplied everything by x squared. And by doing that, we ended up with 9x squared plus 3x minus 2 is equal to 0. Now, although we multiply each side by x squared, we know that x squared cannot equal 0, right? Otherwise, we can't divide by 0. So this is equivalent to the original equation given the restriction. So now we have a, b, and c. We find the discriminant is 81. So we know it's greater than 0, so that has two real solutions. We plug it into the formula, and we get negative 2/3 or 1/3. The quadratic formula will solve any quadratic equation. And that's the end of 1.2. Thank you.